We have two different 30 taper test bars we'll be testing inside this robo drill spindle. We will be trying various retention knobs inside the test bars. We've got two knobs supplied by the customer. We've got three different knobs supplied by a leading retention knob manufacturer. This is inspection of the 150 millimeter test bar, 30 taper. And it shows you, obviously, the test bar itself on V's. You know, run out that's not even measurable, really, less than a micron. And you're talking less than a micron of run out, again. And this is on V blocks, precision V blocks. And this is retention knob number 1, provided by the customer. And this is the runout on the retention knob, using the pilot and the threads to locate the knob inside the ID.
Down on it, the drawbar is going to come down. So you put your piece in there, sit it down on the press, and then press down on it.
60 microns.
That's 60 microns on the shank of the retention knob. The test bar itself is dead accurate, and the retention knob itself is running out about 60 microns. This is knob number 1 supplied by the customer, position number 1. This is a robo drill spindle, 30 taper. The taper runout on the robo drill spindle is less than 1 micron. It's been freshly ground plate ground or GPG'd. And we're getting a runout now of approximately, how much, Wayne?
30 microns?
About 30 microns. Knob number 1, position number 1. Let's move in on that. Okay, this is customer supplied knob number 1 in position number 2. A little different story on this one now. We've got about 10 microns of runout on the end of the test bar. This is customer supplied retention knob number 1 using a 300 millimeter test bar. And we have approximately 40 microns on the end of the test bar. This is retention knob number 2 supplied by the customer. And this is measuring the runout on the shank of the knob, and we're talking about just a little over 20 microns of runout on the knob itself. This is customer supplied knob number 2, position number 1. And we have about 14 microns of runout on the end of the test bar. This is customer supplied retention knob number 2, position number 2. We got 8 microns of runout. So we got a difference of about 6 microns just in that rotation of the tool. This is customer supplied retention knob number 2, measurement with a 300 millimeter test bar. Runout at the end of the 300 millimeter test bar is 30 microns. This is measuring the shank runout of the retention knob. Knob number 1 provided by the US manufacturer of retention knobs. Knob number 1 on the shank, we're getting approximately 42 to 44 microns of runout on the shank. This is a retention knob supplied by a leading US manufacturer of retention knobs, and this is knob number 1. We're getting about 20 microns of runout. Knob number 1 with a US supplier of retention knobs. This is retention knob number 1, position number 2 on the outside supplied retention knob. We have about 12 microns of runout on the end of the test bar. This is retention knob number 1 from a retention knob manufacturer in the US. And this is giving us approximately 32, 34 microns of runout on the end of a 300 millimeter test bar. This is knob number 2 supplied by the US knob manufacturer. This is the runout on the shank of the retention knob. We have 62 microns approximately on the shank of the retention knob. This is knob number 2 from a US knob manufacturer. This is position number 1. We have about 26 microns of runout. 26 microns of runout at the end of the test bar. This is knob number 2, position number 2, and 10 microns at the end of the test bar. This is retention knob number 2 from a US manufacturer of precision knobs. And this is 300 millimeters out on a test bar. We got about 80 microns of runout at the end of the test bar. This is retention knob number 3 provided by the US knob manufacturer. This is the shank runout on number 3. Approximately 220 microns of runout on the shank of the retention knob in the 150 millimeter test bar. This is retention knob number 3 from a US manufacturer of precision knobs. This is position number 1. We have about 50 microns of runout at the end on the end of the test bar. This is retention knob number 3, position number 2. We're about 26 microns on the end of the test bar. This is retention knob number 3 from a US manufacturer of retention knobs. 300 millimeter test bar. We're about 30 microns on the end of a 300 millimeter test bar. 30 microns.
The little black guy.